Hello and welcome to part 2 of the video series on buck converter module BUC01. Today we will regulate the output voltage of the buck converter using a simple potentiometer and thereafter adjust the DC motor speed. The same setup can also be used for LED light intensity control. This is the complete experimental setup. Here we have the buck converter module. This is the input terminal of the module where you can give input supply from 12 to 30 volts. It is connected to Arduino board through these connecting wires. A potentiometer is also used to control the output voltage. At the output terminal, a 12-volt DC motor is connected. Follow this connection diagram to interface buck converter module and Arduino board. And this is the connection for potentiometer. Now let us quickly look into the Arduino program. Here, a PWM header file is included which is required for PWM generation from Arduino. The PWM frequency is set to 100 kHz. Digital pin 9 is set as output. We also set digital pin 12 to 5 volts to power up potentiometer. Here we assign digital pin 9 for PWM generation at frequency of 100 kHz. Inside the loop function, the first step is to read the duty cycle value from analog pin A4. The duty cycle value is mapped within the limit of 0 to 230. After this, the duty cycle value is used to generate the PWM signal. Next step is to measure the upper and lower MOSFET temperature through analog pins A0 and A1. Two functions namely thermistor 01 and thermistor 02 are called. Here are the thermistor 1 and 2 functions which calculates the temperature in degrees and also prints on the serial monitor. Coming back to the main function. We call this function to check the temperatures. In this function we check whether the upper and lower MOSFET temperature are greater than 55 degrees. In case the temperature is above 55 degrees, the program enters the while loop. The module is turned off by this statement. The program then continuously reads the MOSFET temperature and exits the while loop only when the temperature drops below 35 degrees. Our next task is to measure the input voltage and output voltage from analog pins A3 and A2. The following two line converts the analog values to the actual voltage values. Finally we print the input and output voltage values on the serial monitor. Now it's time to upload the Arduino program. Coming back to the practical setup. You can observe the PWM signal coming out from digital pin 9 of Arduino. The PWM frequency is 100 kHz. So now let us start the experiment and switch on the power supply. The input voltage is set at 12 volts. You may now open the serial monitor from the Arduino software. Here you can check out the upper MOSFET temperature. This is the data for lower MOSFET temperature. In the third column you can monitor the input voltage. And finally here is the output voltage. Now we slowly rotate the potentiometer which increases the output voltage. The motor speed is also increasing. The reading of input and output voltage is precise and accurate. You can also notice that the output voltage has minimum noise. Now we are rotating the potentiometer in anti-clockwise direction and the output voltage is reducing. For experimental purpose, here at the output terminal, we have taken two LED light of 12 volts and 9 watts and both are in parallel connection. So here we power up the setup. And then we slowly control the intensity of illumination using potentiometer. Thank you for watching. To perform more experiments using buck converter module, place your order now. Link in description.